without our calculator, all of these values are still true. Alright, so this section has a couple examples. They don't get too specific. We're just going to kind of get our heads around how normal distributions work. So it says the relative frequency distribution represents the heights of a simple random sample of 200 3-year-old girls. There's a table in the book on page 333. We don't really need to see all the raw data, but we have those 200 data points. They gave us the mean of 38.72 and the standard deviation of 3.17. Just for clarity, I'm going to round this off to 39. I'm going to round this off to 3, just if we need to use those numbers, but those are the precise values. They also gave us a histogram drawn to summarize the sample of 200. And just glancing at this, you can see that it's not uniform, it's not skewed, it's nice and symmetric. We can put a smooth curve over the top of it. It's not going to be perfect because it's an actual sample of data, but we can just kind of smooth over and see that it is a symmetrical bell curve. This tells us that we can use all the properties we know about normal distributions. I'm going to leave this page handy so we can refer to these values again in just a minute. So if we were going to find the probabilities, which we'll learn how to do in section 7.2, similar to a uniform distribution, we use the area under the curve to calculate the probability of an interval, whoops, I forgot the R, interval of outcomes. So we cannot find those exact values because of the nature of a continuous distribution. All we can find is an interval of values, less than this, greater than that, between these two. The difference here is that the normal curve is not a rectangle. That's for uniform. Rectangles, we can actually calculate the area ourselves. Curves, unless you've had calculus, we cannot calculate the area. So instead, we use charts or the calculator to find the area under the different pieces of the curve. And we'll learn exactly how to do this in section 7.2. So we don't have a formula we're going to use. Someone's already figured all of this out, and there's a function in your calculator. There's also charts in your booklet, which you might have noticed. There's pages and pages of charts where someone has already done the work for you and figured out all these probabilities. So we'll be referring to one of these charts in just a minute. So here's another example. The total cholesterol for males ages 20 to 29 years is approximately normally distributed. Those are key words, so you can look for those when you're taking your test. Look for those key words. Once you see normally distributed, we should think bell curve. It tells us that the mean is 180 and the standard deviation is 36.2. We want to determine the probability that a randomly selected 20 to 29-year-old male has a cholesterol level above 200. So we're going to draw a normal curve to represent the data, labeling 3 standard deviations out in both directions, just like we did in chapter 3. Alright, so our mean is 180. And we're going to go 1, 2, 3 to the right, 1, 2, 3 to the left, using 36.2 as our standard deviation. So 216.2, 252.4, and one more time, 288.6, and then we'll subtract 143.8. And on your scratch paper for your tests, I highly recommend drawing these out so that you're not trying to hold all this information in your head. You can have as much scratch paper as you need, and you draw as many curves as you need so that you can really see what you're looking at. I always suggest 3 to the right and 3 to the left so that any question that is being asked, you can know where you are on your curve. So again, we're trying to find the probability that a randomly selected male has a cholesterol level above 200. So those are another set of keywords, above 200. Now we don't have 200 exactly down here. We're just going to have to guesstimate that 200 is somewhere in here. So these are not going to fall exactly on a standard deviation like they did in Chapter 3. It'll always be kind of in between a couple, which is why we need the chart or the calculator to help us get these answers. And above 200 would be anything over here. So we're shading the area of interest. I always recommend that as well. Draw that target line. So this is what I call X, or your target value is 200, and then above 200. Technically, remember, this keeps on going and going and going. We stopped it at 3 standard deviations, but it does continue on forever to the right, and technically forever to the left. So it says, suppose the area of that shaded piece, so they've already done the work for you, suppose that number is 0.2903. So we learn how to do this, we get 0.2903. What does that mean? Well, that means that about 29% of males, I just got 29% from rounding this off, 29% of males between 20 to 29 years old have cholesterol, I always spell that wrong, cholesterol levels above 200. So it's the number you're getting is answering your question, and it should always be a number between 0 and 1 to represent the percentages. So the answer you get, you convert to a percentage, and that's what you use to answer your question. Alright, one last example here, and then we'll move on to the next section and actually figure out how they got 0.2903. So here's another example out of your book. This is number 31 from your textbook. It says monthly charges for cell phone plans in the United States are normally distributed. So those are the keywords we're looking for, normally distributed, with a mean of $62 and a standard deviation of $18. So it'll always give you your mean and your standard deviation. As soon as you see the words normally distributed, we're going to draw our curve and label what we're talking about. Always give yourself plenty of space here. You have plenty of scratch paper you can use. And we're going to label it 3 to the right and 3 to the left. So 62, and then add 18, add 18, add 18, and then I'm going to subtract 18, using 18 because that's the standard deviation. Subtract 18, and subtract 18. So these are cell phone rates. Here's your mean, and then your standard deviations 1, 2, 3, 1, 2, 3. Always go 3 to the right, 3 to the left. So shade the region that represents the proportion of plans that charge less than $44. This time 44 happens to be one of our standard deviations. It doesn't really matter. So this is what I call the target value X. And it says less than 44, so we're going to shade everything that's less than 44. Keep in mind this continues on forever, getting smaller. So it says, suppose that the area under the curve to the left of 44, which is the region we just shaded, someone figured out that it's 0.1587. Provide 2 interpretations of this result. The textbook gets a little creative with this. I would round this off to 16%. So I would say 16% of cell phone plans or cell phone rates are less than $44. Your book also turns this into a ratio, 1,587 out of, I believe that would be 10,000. This is in the 10,000ths place. So 1,587 cell phone plans out of 10,000. So cell phone rates are less than $44. So sometimes in commercials, if you watch commercials, sometimes they report the results as a percentage. Sometimes they'll report it as a ratio. Like you'll hear 9 out of 10 dentists recommend this, or 94 out of 500 do this. And so sometimes they'll give it as a ratio, sometimes they'll give it as a percentage. But that is basically saying the same thing. One is a percentage and one is a ratio. So that's just kind of the basics of normal curves. We haven't really figured out how to get this number, which is what we're going to do next. But I'm going to pause here, and I'll pick back up in section 7.2.